I want to paste this picture because it's a great picture that will help us learn and understand more about necrosis and apoptosis. And this picture is coming from Robbins' Basic Pathology text, 8th edition. Kumar is the author. So, let me go back up here real quick. There we go. Okay, so necrosis versus apoptosis. So if a cell, in the first video I believe I talked about how if I was riding a bike and I crashed and I slid on the concrete, how some of those tissues, some of my skin cells would be damaged. Okay, now this is the example that I just used is more of an example of this pathway, which is necrosis. Okay, so necrosis is now both of these pathways, necrosis and apoptosis, are both a way for a normal cell to die. Now, why would you say why would a normal cell die? Well, if there is um, hypoxia. What is hypoxia? Hypoxia means lack of oxygen to some tissues. Um, ischemia. Ischemia is another way of cutting off blood supply to an area. If Why would a cell die? If there were nutrients deficiencies, if there were growth factor inhibition, so if growth factor wasn't being continuously brought towards a cell, it would die. If oxygen wasn't, if some kind of chemical or let's say H2SO4, this is sulfuric acid. It's a very strong acid, very toxic. If that was poured onto your skin cells, they would die. There's a lot of reasons why skin cells would die, and if it's more of an injury, if it's more of this too much for a cell, the cell will the cell will undergo necrosis. Now, how this process happens is this. We'll get into this later. This is just kind of an overview, but enzymatic digestion and leakage of cellular contents. Okay, so let's explain that. Inside each cell are little lysosomes. Let's say this is a lysosome here. Okay, lysosomes have inside of them uh, uh, enzymes. Enzymes are just a specific type of molecules that help speed up a reaction. If you don't understand what an enzyme is, I can make a video on that, or you could just Google it and see if you can't learn a little bit more about enzymes. But enzymes kind of help break down or speed up reactions. And in the case of lysosomes, they have enzymes that degrade contents. Okay, so if you look here at this cell, you kind of can see how this cell membrane isn't attached. There's kind of holes here. There's a hole here, there's a hole here, there's a hole here, there's a hole here. What this is kind of trying to illustrate is that in the necrosis process, the cell membrane has holes. It's not continuous. It it's not. It's broken up. Now, because of these holes, contents can leak out. Okay, and the enzyme or the lysosome that contains these digestive enzymes, what happens is they get broken open. They get split open too, and then they come out and they leak and they start degrading all of this stuff. So lysosomes have these digestive enzymes in them, and usually they're safe inside kind of this little package, but this package gets broken open, gets busted open, and then these digestive enzymes start eating away all of this content of the inside the cell, and breaks open um, this membrane, and then all this content starts leaking out into the extracellular matrix, the ECM, which is extracellular matrix, which is the stuff that's outside of cells. It's fluid, it's collagen, it's fibers, it's extracellular matrix. There's another term um, if you want to Google it to learn more about. Um, but the ECM, so all this stuff starts leaking out into the extracellular matrix out here, and then this necrosis causes inflammation. Now this is the main difference between necrosis and apoptosis. Apoptosis does not cause inflammation, but necrosis does. Okay, and we're going to talk about a lot about inflammation in future videos. I'll talk about acute inflammation and chronic inflammation, and kind of what are the differences and similarities. But as for now, necrosis is this unorganized, brutal way to kill a cell, and usually it's because of some kind of injurious, some kind of stimulus or event that's very injurious to a cell, and kind of, breaks it open, and these lysosomes will start eating away all this content, and it will be ejected or spilled out rather into this extracellular matrix, causing inflammation. Now, apoptosis is a more organized, if you will, organized. Okay, so apoptosis is a programmed cell death. So let's say growth factor. Growth factor is a hormone. Let's say the blood, the blood vessels coming down here, and you got growth factor, in the blood, and it's being transported all over the body. And let's just say this cell, for some reason, does not get growth factor. Whether there's a problem in the blood vessels where growth factor is not leaking out, or anyways, growth factor cannot get to this cell. This cell will take that as a hint that it doesn't need to be alive anymore. So it will undergo apoptosis. Okay. Another example. Let's say you somehow block this blood vessel, okay, through atherosclerosis, or you eat too many hamburgers and your arteries get clogged, and these cells can't get oxygen, or they can't get blood anymore. Ischemia. They can't get blood. They undergo ischemia. That is one of the most common ways that cells undergo apoptosis. They'll start realizing, hey, I'm not getting any blood, and then they will undergo apoptosis. Now, how they do this is they start budding off. They start making these little buds, and then they'll start pinching together. These buds will start pinching together, and this will pop off, this little bubble here, and this will become an apoptotic body. Now, this apoptotic body has, mitochondria, Golgi, has all kinds of different little organelles inside, and this little scavenger cell called a phagocyte will recognize these apoptotic bodies. He'll say, oh, hey, this cell is undergoing apoptosis, so what I'm going to do is I'm going to come over here. He's kind of the garbage man, and he'll come over here and collect all of these apoptotic bodies, and then he'll recycle them. Recycling is a more useful way of getting rid of trash, so he'll go in there and recycle all the contents that it needs, and flush out the stuff it doesn't. So this little phagocyte's kind of the garbage man, if you will, and recognizes that this cell is undergoing apoptosis, and will come over and grab these little apoptotic bodies, these little budding off things, and eat them up and recycle them. Now, like I said, the main difference between necrosis and apoptosis is inflammation. And notice that in apoptosis that this membrane is intact the whole time. And even with these apoptotic bodies, they still have their membrane. And because they're a membrane, this stuff is not leaking out into the ECM. If the stuff was leaking out into the ECM, then apoptosis would cause inflammation. But it doesn't. So, big difference. Necrosis causes inflammation, apoptosis does not. See you in the next video.